Hello, my name is Galo William, and today I will present my PSM1 entitled Effects of Variation Strap Length Towards the Reduction of Liquid Sloshing in a Downscale FLEXITANK. So, the content for this includes introduction, literature review, methodology, expected result, and conclusion. So, the background of study, liquid transportation has become increasingly crucial in today's industry and economy. Uh, the examples of liquid transportation are shown in the figures, such as the ocean tanker, ISO tanker, IBC drums, and also FlexiTank. Since this study focus more on FlexiTank, so the liquid sloshing during transportation is difficult to avoid due to the motion of the free liquid surface inside uh, a flexi tank. So for the problem statement, due to the direct liquid heating action, violent liquid sloshing in big containers can harm the flexi tank and shipping container. So as shown in the figure in the slide, um, the structure of the shipping container is damaged due to the sloshing force caused in the flexi tank. So there are many concepts to reduce sloshing in most rigid tank, but most of them require installation of liquid sloshing suppressor. So for the objectives of this study is to test the effectiveness of using varying length of straps and measure the forces towards the reduction of liquid sloshing in a downscale flexi tank. Second is to evaluate and propose the most effective and practical method to MYF sendirian berhad towards the reduction of fluid sloshing in a downscale flexi tank. And for the scope, shipping container provided by MYF sendirian berhad will be downscaled by 8 times. Second is FlexiTank provided by MYF sendirian berhad will also be downscaled from 24,000 liters to 46.799 liters. And then tap water in UTHM campus Pago will be used as the liquid stored in the downscale FlexiTank. The transportation simulation tester will be used as the transportation simulator in the magma system pengujian of UTHM campus Pago. Force caused by liquid sloshing will be measured using a force sensor, and the experiment will be done according to the repetitive shock test of rotary motion in method A2 of ASTM D999. The strap of 4-meter length is spirally wrapped with 4 turns around downscale flexi tank, and last but not least is the length of strap fastened will be varied to the to test the effectiveness towards reducing the fluid sloshing in a downscale flexi tank. Then moving on to literature review. So this study um, is focused more on FlexiTank. So MYF sendirian berhad is one of the FlexiTank manufacturer. So MYF has since developed to be the premier FlexiTank provider in Malaysia with a growing influence in the global marketplace through its patent, pending design, and constant commitment to research development. So MYF company was founded in 2006, and its headquarters office is located in Sungai Petani, Kedah. So the products that are supplied by MYF Sdn Berhad is the Premier FlexiTank. So this Premier FlexiTank comes with LLDPE with ethylene vinyl alcohol, which is an oxygen and moisture barrier, protecting the customer's product from oxygen and moisture permeation and heat during shipment. Second is the Econ FlexiTank. So this Econ FlexiTank has been specially designed for the carriage of all non-hazardous liquids which are not sensitive to oxygen and moisture, with the aim to provide further cost savings to the shippers. So the concepts to reduce liquid sloshing. Uh, One of the concepts is effect of ball baffles in reducing sloshing. So a study on the efficacy of a set of externally added floating ball baffles were carried out in this study, and its anti-sloshing properties in ship tanks were compared to that of the conventionally used vertical and horizontal baffles. And then ball baffles are an effective alternative arrangement available for reducing sloshing of fluid within a rolling tank without increasing the self-weight of the entire system. So ball baffles are found to be quite effective in mitigating tank sloshing. Second is the use of straps for slosh control in flexible container. So the objective of the previous work is to provide design alternatives while maintaining effective control. So there was a modification of an open box container. Um, so it introduced by using rigid straps at the open top of the container to limit large deflections caused by sloshing. Okay, and moving on to methodology. So this is the flow project as shown in the flow chart. The project will begin with material and equipment selection, and then downscale shipping container and downscale flexi tank, water protection materials, straps, transportation simulator machine will be prepared, and fastening straps around downscale flexi tank can reduce liquid sloshing. And for parameter selection, 46.799 liters of water will be used. 4 meter of ratchet, 4 meter of straps will be used, and the speed of machine on the transportation simulator use is 5. So if the length of uh, strap fastened around the downscale flexi tank can reduce liquid sloshing, then the next process is to be proceed by varying the straps fastened by 85%, 90%, 95%, 100%, and 105%. So the test will be conducted according to the ASTM D99915, and after that a durability test will be carried out. After all the tests are carried out, um, the data will be analyzed and will be discussed. And last but not least is a report uh, to MYF FlexiTank Sdn Berhad. For the materials required, downscale shipping container and downscale FLEXITANK will be provided by MYF Sdn Bhd. Baby swimming pool multi-purpose tray L bracket will be the safety measure materials in case of any leakage that might damage the simulator machine. Force sensor and Arduino Uno will be the material to measure the force caused by liquid sloshing. And transportation simulation tester machine will be the simulator tester machine. A ratchet strap will hold the downscale shipping container on the machine. Cargo strap will be the practical method to reduce the slosh in a downscale uh, FLEXITANK. Last but not least is water that will be obtained from the tap water in UTHM campus Pago. So moving on to experimental design. So for the experimental design, first step is L bracket that are used as barricades will be placed on the horizontal platform of simulator machine. Then a baby swimming pool will be placed on the barricades. After that, multi-purpose tray will be placed in the baby swimming pool. Then a force sensor will be installed in the downscale shipping container. And then a downscale FLEXITANK will be placed inside the downscale shipping container. After that, water will be filled into the FLEXITANK until it is filled to 46.799 liters of water. 4 meters of strap will be spirally wrapped around the downscale FLEXITANK from the front to the back of the downscale FLEXITANK, and the remaining strap will also be wrapped spirally from the back to the front, causing it to cross over on top of the first spiral wrap. So the figure above shows how the straps are wrapped. The red dashed line represents the first spiral wrap and the black line represents the second spiral wrap. Then two ratchet straps will be fastened on the simulator machine to hold the position of the downscale shipping container. After that, simulator machine will be turned on and the speed used is 5, and then the machine will be stopped once it runs in one cycle, and then the force caused by the liquid sloshing will be recorded. So for step number 8 to 12, it will be repeated by using uh, varying length of straps fastened around FLEXITANK, such as 90%, 95%, 100%, and 105%. So for durability test, the simulator tester machine will be turned on for 6 hours with the length of straps fastened that cause the least sloshing force. 6 hours represent the estimated duration for an actual FLEXITANK to arrive from Pago to Sungai Petani, Kedah. The result will be recorded based on how long the wrap can last within 6 hours. Also, if there is any leakage within 6 hours, the machine will be stopped immediately. So for the expected result, it is expected that wrapping spirally with force pressing on top of the downscale FLEXITANK will reduce the liquid sloshing effect due to the suppression of lateral and longitudinal of fluid contents movement under dynamic loads. It is expected that the length of strap fastened at 90% will have the best result in reducing the liquid sloshing in a downscale FLEXITANK. So in conclusion, the use of straps with proper wrapping and tightness is expected to be efficient in reducing liquid sloshing in a downscale FLEXITANK. So the outcomes of this project will not only benefit MYF, Sdn Bhd, but also benefit other liquid logistics in overcoming liquid sloshing in FLEXITANKs.